Again, this is a recording that serves a dual purpose of looking at a sample calculation for Lab 1 on density, as well as for looking at certain aspects for a lecture such as significant figures, units, errors. So here I want to talk about qualitative errors, and I do it in the context of actually writing the conclusion for this particular lab. And here for the conclusion I would say, and of course this is mine, so don't copy it. For my conclusion, I would say my result of 12 grams per cubic centimeter is relatively close to the accepted value of 11.35 grams per cubic centimeter. Within my error range that I computed. And the other one then would be minus what would be my result for lead, right? And then the other one would be my result of 10 grams per cubic for galena, which is lead ore, which is different. That's lead sulfide, it's a different compound. Is, well, somewhat close. I used the word ballpark, is in the ballpark when compared to the accepted value of 7.4. Still within my relatively large error range of 40%. So that or similar is what you would write. Now you also have to say what kinds of errors you encountered. So I always put a footnote on there that says the conclusion, of course, includes your assessment of the results, which is what I just did, and your error analysis, what could have caused random systematic errors, and be specific, mentioning friction without any specific errors. Simply mentioning an injudicious human error automatically leads to fewer points. So if I wrote down now that my measurements were influenced by human error, that automatically leads to me taking points off, because that absolutely has no meaning. What does that mean? Human error. I have no idea. You have to be specific in detail. By the way, as I'm typing here, of course, I'm taking up time, but I want to show you that, well, you have to put a certain amount of thought into it, and that takes, of course, time. Okay, so here, my measurements, perhaps I could express it as contain the following errors. And as I type here, and I'm speaking English in a second language, as I'm German, I may actually want to revise my sentence as it goes through. I guess I'll see how this turns out. So my measurements contain the following errors. Measuring with the metric tape, with the measuring tape. So measuring tape where I could have plus minus the 0.05 centimeters, so it's an estimated 0.1 centimeters or 0.05 centimeters within the divisions. Notice that the box does get larger, so you're not necessarily confined to the text box size that I gave you. It is the spring scale. The spring scale that is, I express a little bit different. That's up to you how you express it. Accurate to within a few grams. And by the way, each one of these two here are actually random errors. Then I could say, well, what if I didn't tear my spring scale correctly? That means the original way of zeroing it. So the word would be to tear or zero the spring scale correctly, which is a systematic error. Let's say I had forgotten that. But since I shouldn't forget it, a systematic error is to be avoided. And the same for the measuring tape that I used. So tear or zero the measuring tape. I think I showed that in the video as well, that if I start at the wrong point, they're not at the zero, but at the end of the measuring tape, that is not the same. I think I used a ruler actually. So measuring tape or ruler and spring scale, I get a systematic error that I should avoid. Now, in my case, you may have seen it as I hooked on the lead cube. You may or may not have noticed that there was a little hook on the top, which is actually a brass hook. So my lead cube actually contained a brass hook that should not be measured. But I tried to take it off beforehand and I couldn't, and besides it was actually convenient to hook it onto the spring scale. So my lead cube actually contained a brass hook that should not have been measured, but it did, and again that would be a systematic error, which in this case I couldn't avoid. Then I definitely saw that my lead cube, actually lead is relatively soft, was actually chipped. So lead cube was chipped, and because of that, the volume that I measured was perhaps a little bit too large than what it should have been. And in this case, I really couldn't avoid that, but I have to note it down. And that is what I would expect in a conclusion. I believe I'm done here with my qualitative errors. There isn't much more that I could do wrong on trying to measure the dimensions and the mass of a specimen. So that's how it would look like. You come up with comparing your results, and then you come up with an error analysis. And usually, as I said, that's going to be qualitative, just the way I wrote it here. And only for this particular lab did you have a computational error.